Here we continue with the question number 3, talking about the immunological memory. When an organism encounters the same pathogen more than once during its lifetime, the immune response against this pathogen becomes more and more efficient. The flu virus exists in different variants, having different antigens. We studied the immune response triggered by individual upon contact with the flu virus 3 times during his lifetime. The document shown in document 1 presents the age of this individual at the time of contact with one of the 3 variants of the flu virus and the evolution of the amount of antibodies specific for this antigen of variant 1. So this document is showing the age of the individual at the time of infection, the antigens of the variant, and the evolution of the amount of antibodies specific to the antigens of the variant 1. So here, let's start step by step. We have 2 years individuals in contact with variant 1 of the flu virus. Here we have antigens A, B, C, and D. These are antigens of the variant. Evolution of the amount of antibodies specific for the antigen, amount of antibodies specific for antigen A, antigen B, antigen C, and antigen D. As you see, all of them, they are constant. They are one arbitration units, one AU. So all of them, they are constant. Wait a minute. First, before we continue to solve any part of this question, you have to know that here we are working about the specific humoral immune response. Why? Because we have the secretion of antibodies against specific antigens. We have antibodies. So this is the first note you have to know. Before you continue, before you start to solve any question, or you have to start to think of any part of this question, you have to know that we are talking about antibodies, specific humoral immune response immediately. This is the first thing. Second, the same individual at the age of 5 years, after 3 years, in contact with variant 2 of the flu virus. Variant number 2. Variant 2 of the flu virus contains antigens A and C. They are common with the variant 1, but we have here E and F. If you see here, the amount of antibodies against A and C, they are higher than those for D and, for example, for those of D and B. Why? Because they encountered the same antigens twice, at the age of 2 years and the age of 5 years. So the amount of antibodies against A and C, they increased higher than that of B and D. Why? B and D, they encountered them only once during the age of 2 years. So the amount of antibodies here, they increase about 5, here it is about 6. Okay? The same individual at the age of 20 years in contact with variant number 3 of the flu virus. Variant number 3 contains the antigen A, G, D, and E. So A and D, they are common at the age of 2. While G and E, they are common with age of 5 and E, and the G, it's in U1, new antigen. So let's see the amount of antibodies against the specific antigens. The amount of antibodies against A, they increase. If you see here, there was 1. Then they increase after the second encounter to 5. Then here they increase to about 8 AU. While those of D, they increase to about 6 AU. So after the second encounter, after the secondary response, the amount of antibody will increase to a higher value. This explains that the secondary immune response is more amplified. Some of you are going to say more amplified, more persistent, it's faster. Wait a minute. They didn't say about time. They didn't say about the duration. You're talking about only about the amount. So you don't have to add any additional information. Even though you study these and you know this, you don't have to add them. You have to be specific in this point. In this question, we're talking about the amount of the antibodies. So the amount of the antibodies, we're going to go about amplification, high amount of antibodies secreted. First one, part number 1. They said that name the specific immune response revealed in the above document, justify your answer. Already we said that the type of the immune response is specific humoral immune response because we have high amount of antibodies secreted. Justify the following statement. They said they defined the following statements by referring to the document. So according to the document, you have to justify each of the following statements. Part A, the secondary immune response is more amplified. Already we said that the secondary immune response is more amplified since we have higher amount of antibodies. Since the amount of antibodies after the second contact and the third contact, they are higher than after the first contact. So this explains that the immune response or the secondary immune response is highly amplified compared to the primary, because we have higher amount antibodies in the secondary immune response. B, the secreted antibody is specific to the antigen and not to the variant of the virus. Let's explain this and document in part 2. The antibody is specific to antigens A and C and not specific for the variant, for example, not specific for the virus. For C, the organism keeps memory for encountered antigen for more than 10 years. Yes, for more than 10 years, and even though for about 18 years. If you see here 2 to 20, the amount of antibodies against antigens A and D, they increase after the second contact with them. This explains that the keeps memory cells, they have a memory, immunological memory against these antigens for more than 10 years, this is approximately 18 years. So you have a memory that studies these antigens and remembers them and takes the action by secreting a high amount of antibodies specific for them. Okay? Part 3, name the two cells. Let's first solve the first part. Question number 3, you said, what is the type of the immune response? It's specific humoral immune response. Why? Because after the entry of the virus, if we have antigens A, B, C, and D, the amount of antibodies, they increase, they rise to about 1 AU, meaning that we have secretion of antibodies, so thus the immune response is specific humoral immune response. And part 2, they said in part 2, A, secondary immune response is more amplified than the primary. During the first contact with the variant 1 of the flu virus at the age of 2 years, the amount of antibodies that are specific for antigens A, B, C, and D, they are 1 AU. All of them, they are 1 AU. This can be explained that we have a primary immune response. This is the first encounter or the first reaction between the antigen and antibody is called the primary immune response. However, the second contact with the antigen at the age of 5 years with variant 2 of the flu virus, having the antigens A and C in common. If you remember, with variant 1, the amount of antibodies specific for A and C, they increases to 5 and 6 AU respectively, which is greater than the first encounter, which was 1 AU. While the amount of antibodies specific to B and D, they remain low. So this indicates that the immune response triggered upon the contact with the same antigen or the secondary immune response is going to be more amplified than the primary. So you have high amount of antibodies after the same contact with the same antigen for the second time, which is called the secondary immune response. For B, they said the secreted antibody is specific to the antigen and not to the virus, to the variant of the virus. During the third contact at the age of 20 with variant 3 of flu virus, having the antigens A and D in common, only the amount of antibodies specific to these antigens increases to 8 AU and 6 AU respectively. Thus, the secreted antibodies, they are specific only to the antigens and not to the variant of the virus. Part 3, talking about the immune memory, you have to say that the organism keeps a memory for the encountering antigen for more than 10 years, in this case about 18 years after the first contact at the age of 2 years. Or you can say that the amount of antibodies remains constant at 0.5 AU from the age of 5 to the 20 years. Let's move now to part 3. Part 3, they said the name the two cells implicated in the immune response triggered against the variant 1 of the flu virus and specify the role of age. Here we are going to talk about the phagocytes and we're going to talk about the B lymphocytes. What do they do? B lymphocytes will develop into the plasma cells that are able to secrete antibodies, but the secretion of interleukin by the B lymphocytes. Explain why the secreted antibodies contribute to the destruction of the virus and specify if the revealed immune response is carried alone to eliminate the cells infected by the virus. Justify your answer. So first, you have to say that macrophages, phagocytes, after phagocytosis, they become what? They become APCs. What the meaning of APCs? Antigen presenting cells that activate the T4 lymphocytes. T4, whenever they are activated, they secrete interleukin that this interleukin 4 activate in return the B lymphocytes. B lymphocytes, they have antibodies. They have to identify the free antigens through the membrane antibodies to be activated, and the plasma cells, they secrete specific antigens. So here we can say about the macrophages, about the plasma cells or B lymphocytes. Okay. Part 4, the specific antibodies, they neutralize. Here, part 4, the most important word that you have to mention, and you didn't mention it, approximately half of the mark will be eliminated. In 0.5 marks, we're going to get 0.25 if you were perfect. So you have to say opsonization. Opsonization. Opsonization, you have to say that whenever the antibodies neutralize the antigen of the two viruses by binding to them with specific antigen, forming immune complexes. These antibodies, they become able to bind with their counterpart to macrophages that perform the process of phagocytosis that destroy and phagocyte the whole immune complex antigen antibody by a process which is called opsonization. And part 5, specify if the revealed immune response is capable alone to eliminate cells infected by the virus. Justified answer, no. Why? Since the infected cells cannot be identified by the antibodies, which block only extracellular antigens. Moving to question number 4, talking about the female cycle, sexual cycle, estrogen, progesterone, LH, and so on. So first of all, in order to determine the reason of sterility in a 30 years old woman, gynecologists prescribe the determination of estrogens and LH hormones level in the course of a sexual cycle. The obtained results are shown in documents 1 and 2. So we have in document 1, we have the variation of the amount of estrogen in picogram per milliliter as a function of time and days. And also in document 2, we have the variation of the amount of LH in milligram per milliliter as a function of time and days. So here, part 1, they said draw up in the same table the variations of the plasma amount of estrogen and LH in this woman. So both of these graphs should be drawn in the same graph. Both of them in the same table, sorry. So both of them should be drawn in the same table like this. So you have to put both of them in the same table. Amount of estrogen picogram per milliliter, that of LH and MIU per milliliter, and the same table. So you don't have to put only estrogen, or you don't have to put only LH. If you did so, mean that you missed the mark of the table. Second, you have to put the title for the table. You have to draw it using a pencil, and you have to give it a title. And this table should include, as I said before, both estrogen and LH. Okay, so they said part 1, it's almost done. So table. Advanced analysis shows the production of normal gametes. The doctor affirms that the result shows an absence of disturbances in the functioning of the hypothalamus, the pituitary, and the ovaries, and the anomaly mainly in genital ducts. By referring to documents 1 and 2 and to your acquired knowledge, so you have to use your acquired knowledge. Testify the doctor's affirmation. So say why the doctor, I'll prove that the doctor is correct, that the anomaly is mainly in the genital duct. So here, we say that the amount, as they move, for example, from 0 to 10, the amount of estrogen increases from 60 to 240. And that of LH is moving from 0 to 10, it increases from 5 to about 13. So here, you have to say that the woman produces normal gametes. This is the affirmation of the doctor. We show that we have a normal state of endocrine and ovarian function. The result obtained indicate that we have an increase in the amount of estrogen between 0 and 10. This will indicate that we have normal development of what? Of the follicles. While the estrogen on the day 12 will provoke a feedback. So estrogen peak on day 12 will have a positive feedback in the hypothalamus pituitary axis, which is explained by the peak of LH on day 14. This will induce the ovulation. So this peak of LH at day 14 will have the ovulation. So the problem is not in the hormones, the problem in the genital duct. Name the technique that allowed the treating this hormone sterility, in vitro fertilization, and embryo transfer. If you said only IVF, that's not correct. You have to mention both of them. In vitro fertilization and embryo transfer method technique. Document 3 reveals the amount of estrogens and LH in another woman of the same age who also suffers from sterility. So also this woman suffers from sterility. At day 0, the amount of estrogen was 29.1 picogram per milliliter, and that of the LH was 5.3 MIU per milliliter. As we move for day 4, the amount of estrogen decreases back to 0, and then it decreases to become approximately constant. By that of LH, it decreases and then increases at day 12, and then decreases, and so on. It fluctuates. So have fluctuation. So here you have during 20 days, 28 days, the level of estrogen and LH in the woman remain constant. the amount of estrogen fluctuates. So estrogen level fluctuates between 29.1 and 30.3 or 30.4. And that of LH fluctuates between 5.3 and 7.3. So this means, or this indicates, or this implies that there are no cyclic variation for the amount of estrogen and LH. There is no cyclic variation. They fluctuate at a normal or approximately at a very close levels. Point 5, explain the probable origin of the woman's sterility. What is the problem? What probable origin? So there is a problem in the hypothalamus pituitary axis, at the level of the hypothalamus pituitary axis. This is the problem is at this level. So the measurement of the hormone level done in this woman will be the absence. We don't have a cyclic variation of hormones. They fluctuate approximately at the normal levels or at the very close levels. So the release of estrogen at day 12 should trigger the peak of LH. So at day 12 here, so we should have a peak of LH. So we don't have a peak of LH. Therefore, the absence of the peak of LH will lead to the absence of the ovulation. So therefore, the probable cause of sterility in this woman is deficiency of estrogen that block the LH that will lead to the ovulation, as I said. So this means that the sterility is only to the disturbances in the functioning of the hypothalamus pituitary axis to the ovaries, either in the hypothalamus or in the pituitary or in the ovaries. So what is the treatment? Treatment is given a strong dose of estrogen that will lead to the peak of LH, that will lead to the appearance of the ovulation, and this will solve the problem of the sterility in this female. So the problem in this female is due to the abnormality at the level of the hypothalamus pituitary axis, at the hypothalamus or the pituitary axis or the level of the ovaries. So the treatment should be doses of estrogen. These doses of estrogen will induce the peak of LH at, that will lead to the ovulation, and this will work normally. So the problem for this female is only a disturbances at the level of the hypothalamus pituitary axis. For the name of the technique, you have to know the Viking technique, the impetus fertilization, and implant transfer. You have to know that whenever you have approximately no cyclic variation, so no changes at the level of estrogen and LH, so this problem at the level of the hypothalamus pituitary axis, you have to be careful for the table, how to draw it, how to draw both of them in the same table, and not to draw only one. Also, you have to know, according to the immuno exercise, they have antibodies, so the immune response is specific humoral. You have to know that secondary immune response is more amplified, so you have high amount of antibodies. You have to know that the secreted antibody is specific for the antigen and not to the variant of the virus, since the amount of antibodies will increase according to the antigens and not to the variant of the virus. And you have to know that after 18 years, from the year of 2 to the year 20, the amount of antibodies they increase after they encountering the same antigens, which are A and D. So this explains that we have immune memory. You have to know that phagocytosis, they have a role in the immune response against the flu virus, and phagocytosis the phagocyte becomes APCs, and they activate the T4 lymphocytes. T4 lymphocytes, they secrete interleukins. These interleukins activate B lymphocytes to become plasma cells and secrete antibodies, and these are involved in the process and of the immune response against the flu virus. Okay,